Hello students, welcome to Narayan PU College online classes. Now continuation here, preparation methods of alcohols. And previous we have discussed some methods. Now the next method is from the Grignard reagent. Okay? So Grignard reagent, alcohols are obtained when Grignard reagent is reacted with the carbonyl compounds, that is aldehydes and ketones. Okay? So here, first I will write the general equation how carbonyl compounds are converted into alcohols reacted with the Grignard reagent. You know, previous I have already mentioned carbonyl compounds means and C double bond functional group containing compounds. We will call it as a what it is carbonyl compounds. When carbonyl compounds are reacted with Grignard reagent, in the previous chapter we have already discussed about the Grignard reagent. And the general formula for Grignard reagent is RMgX. Okay? So when carbonyl compounds, it can be aldehydes or ketones. Now, what is the compound unit? See first one. You know that when there is a carbon is attached to the oxygen with the double bond, you know oxygen and carbon, which one is more electronegative? Oxygen. So that's why these bond electrons will shift towards the oxygen. So oxygen is getting electron and carbon losing the electrons. So that's why, and losing electrons means it acquires the partial positive charge and oxygen will acquire the partial negative charge. And come to here, Grignard reagent. You already know Grignard reagent. And Grignard reagent, it is a metal. The bond between the metal and the carbon, if you see here, and in this one, metal donates, always metal is electropositive, so that's why when the bond breaks, and you know always carbon gets the partial negative charge and it is a partial positive charge. Metals are always electropositive, they donate the electrons to here alkyl group. Now reaction is over. So negative charge attack at the positive charge. Then this double bond electrons will shift towards which one? Oxygen. Oxygen is a negative charge and magnesium is a positive charge. There will be a bond. Then what happens you see? And you will get the compound is, and here there will be a R and here O minus and Mg plus. There will be a bond MgX. And next we have to do the hydrolysis. Hydrolysis, acidic hydrolysis you can do, or dilute HCl4 you can use, and also sometimes aqueous ammonium chloride can also be used for the hydrolysis. So simple here, hydrolysis. When do the hydrolysis, this bond will break and here H and here OH will be added. Then what the compound you are getting, you see, and this is a R and here OH plus MgOHX. This is what it is. It is a alcohol. Clear? So this is carbonyl compound. This is carbonyl group. This is carbonyl group. You see? And whenever Grignard reagent react with the carbonyl compounds, we are getting which one? Alcohols. Very, very important this is. And first one, and I will write here formaldehyde. I will treat means when Grignard reagent react with the formaldehyde, which compound you will get. Clear? So now I will take the formaldehyde. You know the formaldehyde, what is the formula of formaldehyde? This is the formaldehyde. This is formaldehyde. Clear? Formaldehyde. When formaldehyde react with Grignard reagent means I will take here CH3 MgBr, one of the Grignard reagent. Then you know the same reaction. Here the charge here, negative charge, and it is a positive, and this bond breaks negative, and this is a which one? Positive. Then reaction takes place here, this bond will shift here. Then what you will get, you see? CH3 and here H and H, CH2 and here O, and to the O negative charge and Mg plus. So there will be a bond, negative and positive, there will be a bond. This is. Yeah? And next one. Same, you have to do the which one here? Hydrolysis. Do the hydrolysis and break this bond H and OH. Then what you are getting here? CH3, CH2, OH, and MgOH, Br. See what you are getting here? You are getting ethyl alcohol, or you can simply say it is a primary alcohol. It is a which alcohol? Primary alcohol. Because OH is attached to which group? CH2 group, so that's why it is a primary alcohol. Means when I take the formaldehyde, react with the Grignard reagent, then you are getting which alcohol? Primary alcohol. Because competitive examination, this type of questions will ask. Whenever formaldehyde react with the Grignard reagent, which of the following compounds will form? Primary, secondary, tertiary, or none of them? Here, simply what it is? Primary alcohol. And now I will take the here aldehyde other than the formaldehyde. Take aldehyde other than formaldehyde. Suppose I will take here acetaldehyde. What is the formula of acetaldehyde? CH3 C double bond O and here H. This we will call it as acetaldehyde. This is we will call as this one acetaldehyde. Here now same treated with the Grignard reagent MgBr. Again I will not write positive and negative, you already know. So CH3 attack here and O minus will means bond electrons will shift towards the oxygen. Then what the compound you will get to see? There is a CH3 and this CH3 will be added. So that's why CH3 and H will be there. H and O MgBr. Because migration positive charge and O negative charge, positive and negative there will be a bond. And here carbon positive charge CH3 minus. So there will be a bond. So that's why same and do the hydrolysis. And when you are doing the hydrolysis, break this one H and OH. Then what the compound you will get? C and CH3 and here OH plus MgOH Br. Which alcohol it is? You are getting secondary alcohols. You are getting which alcohol here? Secondary alcohol. Now I will take here. Third one is ketones. These two are aldehyde. Formaldehyde, primary alcohol. Other than formaldehyde, any aldehyde you take, then you will get the secondary alcohol. Because if you take aldehyde means there will be one alkyl group and another alkyl group will come from the Grignard reagent. So two alkyl group will be added to the carbon of the CO. Then automatically you get the same alcohol. Next one. Ketone. I will take here acetone CH3 C double bond O and here CH3 plus CH3 MgBr. CH3 MgBr. Same here. And this is what it is, acetone. This we will call as acetone. Now same reaction. Positive charge, negative charge. There will be a bond and negative charge, positive charge. There will be a bond. And now you will get CH3 and two CH3 groups are there and here CH3 group and another CH3 group will come from from Grignard reagent and O is there O MgBr and same here hydrolysis in presence of acidic medium then and here H OH then you will get the compound is CH3 and CH3 OH plus MgOH Br. This which alcohol here? It is a tertiary alcohol. It is a which alcohol? Tertiary alcohol. You see now, very important point we have to mention here. If you take formaldehyde, take the formaldehyde and it is treated with the Grignard reagent RMgX followed by the hydrolysis, you will get the alcohol is primary alcohol. And other than formaldehyde, take any aldehydes. Take the here aldehyde and here Grignard reagent RMgX and H2O followed by H2O, you will get the compound is always you will get the secondary alcohol. And next one is if you take the ketones, when ketones react with the Grignard reagent and H2O followed by H2O, you will always get tertiary alcohols as a product. This is very important for the competitive examinations. Okay, so this is about Grignard. Next one, whenever Grignard reagent reacted with epoxide and we will get the alcohols. Grignard reagent RMZX. This is Grignard reagent. Epoxide, cyclic ethylene oxide. We will call it as epoxide. This is the structure. And CH2, here CH2, and this we will call it as epoxide. Yeah. So now what happens here? So whenever Grignard reagent is there, you know it is a 3-member ring, and 3-member ring means it is unstable because it feels some angle strength. So that's why always it try to open its ring. Yeah, and it always try to break its ring to get it off from angle strength. So that's why what happened here, the RMGX, you know already it is a partially positive charge, and this is a partially negative charge here. Then remember always here ring opening from the Grignard reagent follows the SN2 mechanism. It follows the what it is SN2 mechanism. It attacks any one of the carbon because both the carbons are same. Then automatically what happened here? These bond electrons will shift towards the oxygen. Yeah, and because here oxygen already having the 4 bonds, and another bond is making the R, so that's why carbon having 5 bonds and carbon should not have the 5 bonds, so that's why this CO bond will break because it is a more polar. So then what the compound you will get to see here, oxygen gets the oxygen gaining electron means negative charge, and it is making bond with the positive charge, so that's why you will get the compound R, you know here CH2, R here CH2, and the next CH2, and this bond breaks, and this is R is attached to this carbon, CH2 to the CH2, which one is there? O, MZX, because it is O negative and magnesium positive, there will be a bond. You can write simply here MZX. Then next one what it is? Hydrolysis, followed the hydrolysis. Now what the compound you will get? HN, OH. Then what the compound you will get? R, CH2, and here CH2, OH, and plus MgOHX. This is, so what you are getting? We are getting the alcohols from the reaction of Grignard reagent and epoxide. It's alcohol we are getting here, primary alcohol. And second one, same another one example I will take, and RMZX. Suppose I will write here epoxide. This is epoxide, and I will write here there will be a 1 group CH3. Okay. Next, I already mentioned now. It is a positive charge and here it is a negative charge, and R can attack on the first carbon and also second carbon. There are 2 chances here, but I already said it follows which mechanism? SN2 mechanism. SN2 mechanism means you already know, and nucleophile it attack from the means it attack the carbon where the bulkiness is less, because it has to attack from the backside. Backside means there should not be a bulky group, so that's why. And R attacks the where the carbon is free, so that's why. And this bond and will go towards here. So then what the compound you will get here? You will get the compound is here. You see this is CH2. R will be added here. R. You will get here CH2, and here what is there? CH, and here CH3, O, MgX. Then what will happen here? H2O. So hydrolysis means H and OH. Okay? Then what the compound you will get? R, CH2, and CH3, and you are getting here OH plus MgOH and X. Yeah? So this is the, and we are preparing alcohols from the which one here? Grignard reagent and epoxide. Yeah, so this is the another method. Now, second one is from acid derivatives. Acid derivative means we have acid chloride and esters, acid anhydride. Yeah, whenever Grignard reagent react with the acid derivatives, means when you use the Grignard reagent excess amount, you will get the always tertiary alcohols as a product. Okay, simple. I will take the acid chloride here. You know acid chloride means RCOCl is a acid chloride. Clear? So now, when it is reacting with the Grignard reagent, you know, this is the Grignard reagent. Same, previously we have mentioned it is a negative charge and a positive charge, and carbon gets the negative charge, sorry, oxygen gets the negative charge, carbon gets the positive charge, positive and negative, there will be a bond. So what the compound you will get, you see, R, and here I will get this is R dash, and you know, COMG X, and here there will be a R, and here there is a C. See, no, you know that Cl is a very good leaving group, so that's why. And this bond comes here, and it bond C it is a previous single bond, now it will become a double bond. When it is become double bond, carbon is having 5 bonds, so that's why chlorine it leaves. Clear? So what you will get the compound, you will get R, C double bond O, and R. This is plus Mg. You know, this is a byproduct. Mg, if it is X, you will get MgX2. Otherwise, I will write Cl and X. Clear? Now, you see, this is aldehyde. This is your, if you are getting which one here? Ketone. And you know already ketone. Again, react with the RGX. What you will get? Tertiary alcohol. Again, it will react with RMgX, and it will give R dash. And here COH followed. I will not write again mechanism here. R, and you know, 2 groups you will get. So which alcohol you are getting? Tertiary alcohols. Clear? Very important this is. And it is a acid chloride. In the same way, if you take the esters, are acid anhydrides, and treated with the Grignard reagent. Take the Grignard reagent, how many moles here? 2 moles, or we can say sometimes excess also. Excess. Then which alcohol you will get here? You will get the tertiary alcohols. Tertiary alcohols. One is alkyl group is from the acid derivatives, and 2 alkyl groups from the Grignard reagent. If they give 1 mole means you will get which one? Ketone, because this is acid chloride react with 1 more Grignard reagent, you will get the ketones. If you use more than 1 mole, means 2 moles are excess amount. What is the product here? The final product is tertiary alcohol. So along with this, you have to remember acid chlorides, and esters, and also acid anhydrides. Acid anhydrides. Clear? React with excess of RMgX followed by hydroxide. This is how many moles you have to take? 2 moles are excess amount. Then what is the product here? Tertiary alcohols are the product. If they give 1 mole, ketones are the product. Okay? So this is about the preparation of alcohols from the Grignard reagent. So we have completed preparation methods of alcohols. Now next one is preparation methods of phenol. Yeah. So phenol can also be called as carbolic acid. Sometimes in the questions they have given what is the other name of phenol? Carbolic acid. Clear? So what are the preparation method? The first preparation method is from haloarenes. This we have already discussed. From haloarenes. This is we have discussed in the haloalkanes and haloarenes, and this process we will call as Dow's process. Dow's process. Clear? So what is the Dow's process here? We will take the haloarene. Haloarene means, shall I take here chloro-benzene? Haloarene this is. And whenever haloarene is treated with the NaOH, whenever haloarene treated with the NaOH at 623 Kelvin and 300 atmospheric pressure, because you know that, and it is haloarenes. Haloarenes will show the less reactivity towards the nucleophilic substitution reaction. So that's why we have to maintain the drastic conditions, like we have to maintain the high temperature and high pressure, then only the reaction takes place. Clear? Then what happened here? And first chlorine will be substituted by which one here? And OH, that is chlorine is substituted by the OH. Means OH means, you know, we will discuss acidity of the phenol. Phenol are acidic in nature, but which solution we have used here? NaOH. It is an acid and solution we have taken as a base. So that's why we will get the first of all and sodium phenoxide. Clear? So what we will call here? Sodium phenoxide. It is a salt. Sodium phenoxide. And then you have to do the hydrolysis. Do the hydrolysis by using the HCl. Whenever hydrolysis you do HM and here Cl, then what the compound you will get? You will get the compound is OH and plus NaCl. This is the what it is preparation method of, you know, phenols from which one? Chlorobenzene. That we will call the process as a Gauss process, and we have to maintain very drastic conditions, as you know. And chlorobenzene and will involved in the nucleophilic reaction very slowly, because here the bond is not a single bond; it is a partial double bond character. And the next second method is from benzene sulfonic acid. Second one is benzene sulfonic acid. Benzene sulfonic acid. Next one is from benzene sulfonic acid. From benzene sulfonic acid. You know what is the benzene sulfonic acid? On the benzene, SO3H should be present. And how we will prepare that one? Take the benzene and do the sulfonation. You have studied that one in the, you know, first year. Sulfonation, chlorination, nitration, and sulfonation. And do the sulfonation here by taking the concentrate H2SO4, or we can take H2S2O7. This will be called as a oleum. Yeah? And then you will get the compound is benzene sulfonic acid. This is called as benzene sulfonic acid. This is a benzene sulfonic acid. Now, whenever this benzene sulfonic acid is treated with the base NaOH and again after that followed by hydrolysis, then what it is? SO3H is a very good leaving group. Very good leaving group, and ONA will be added here followed by the hydrolysis. You will get the compound is here phenol OH. Okay, so this is the preparation of which one here phenol. You may get doubt here how this will be removed, and simple you take here SO3H. This is the SO3H. First we are treating this one with which one? NaOH. It is not required, just I am saying. And it is a base and it is a acid, sulfonic acid, benzene sulfonic acid. It is a base. Base and acid you will get the salt. What is the salt here? SO3 Na. And again it is treated with the 2 moles of NaOH. Treated this one with the 2 moles of NaOH. Then what happens? You see, you will get the compound is Na2CO3 will be removed. Na2 SO3 will be removed here. 2 Na and SO3 will be removed here. And also H2O will be removed. And here 2 OHs will be there. 2 OH means what we can write? H and OH. H2O will be removed here. O will be there. ONA will be present here. So that is ONA. You will get the which one? ONA followed by which one? Hydrolysis. Understood or not? Na2 and SO3 will be removed as a Na2SO3. And 2 OHs are there. 1 H and OH will be removed as a H2O. Which one will be left here? O, and here which one is left here? Na, ONA. And do the hydrolysis, you will get the OH. This is the preparation of phenol from which one? Benzene sulfonic acid. Third one is from diazonium salts. Third one is which one? From diazonium salts. This also we have already discussed in the haloalkanes and haloarenes. So what is this one? And we know how to prepare the diazonium salts. We have discussed it in the haloalkanes and haloarenes, that is Sandmeyer reaction. Have you remembered or not? Yes? And here, how to prepare the benzene diazonium chloride means we have already discussed, that is, we will take the aniline. What is the name of this compound? Aniline. This is the aniline. Clear? When aniline is treated with HNO2, or sometimes they will give NaNO2 plus HCl. directly sometimes H and O2 also they will give, and maintain 0 to 5 degrees centigrade. Then this aniline is converted into benzene diazonium chloride. Benzene diazonium chloride, plus and minus. That time this is N2 means diazonium, it is a salt, diazonium chloride. Clear? Now treat this one with the warm water. Clear? Then what will happen? You know, N2 is a very good leaving group, and OH will be added here. You will get the compound is, and N2 is substituted by the OH, and N2 will be removed, and here OH means one H will be left, and here Cl, and you will get the HCl. What you are getting here? You are getting here. This is the third method how to prepare the phenols from the diazonium salts. And very important fourth one is from cubene. From which one here? Cubene. Very important for your PU examination also. Put the star mark here. Very important for the PU examination. Most of the time this question asked in the PU examination. So preparation of phenol from the cubene. What is the cubene? Isopropyl benzene we will call as a cubene. What it is? Isopropyl benzene. CH3 and CH3. This is isopropyl benzene. You already know this group we will call as a isopropyl group. CH3 group we will call as a iso. This is iso. 3 carbons are there. Propyl, isopropyl benzene. Okay? And what we have to do? First, we have to treat this one with the oxygen, aerial oxidation. We will call what it is? Aerial oxidation. Clear? So, cubene is converted into, whenever we do the aerial oxidation of cubene, and here 2 oxygen atoms are inserted, you will get the peroxide. You will get the which one here? Double O, single bond O, 2 oxygen atoms attached to each other means we will call this one as a peroxide, cubene hydroperoxide. Cubene hydroperoxide. Cubene hydroperoxide. This is clear. Next, what you have to do? Do the hydrolysis. Do the hydrolysis in the acidic medium. Do the hydrolysis in acidic medium. Then what happened here? You will get the compound is phenol. You will get the compound is phenol, and along with the phenol, you will get the compound also aceto. You will get the compound here, this one here, aceto. Clear? See, just what happened, realignmentation that is not required here, and benzene will shift here, and this bond will come here. It will C bond converted into double bond, and you will get the phenol and aceto. Yeah. So these are about the preparation methods of phenol. First one is from haloalkane Dow's process, sulfonic acid, from benzene diazonium chloride. Last one is cubene. Very important. This we will call as a phenol. And what is the byproduct in here in the preparation of phenol from the cubene is aceto. Yeah. See here one question. Till now what we have discussed, based on that some questions they have given in our answer test book. That is 11.5 and page number is 320. Yeah. So 11.4 also there, and first I will discuss this, and after that I will go for the 11.4. See here, alkene H2O plus H. We have already discussed this one. What it is here, and in the first one preparation of alcohols, first concept is by acidic catalyzed alkene, by alkene acid catalyzed hydration. Have you remembered or not? That is the question. So just what you have to do is carbocation will be formed here. That because here there is no rearrangement. So that's why simply add the water according to the molecule count. Because double bond is there, what will you have to add? So which rule you have to follow? Molecule count, there is no peroxide. So that's why you know what the compound you will get. CH3 and the COH and here CH3. Because OH minus added to the double bonded carbon where the number of hydrogens are less. Yeah. Next one is important. You see, I have given table. This is sodium borohydride and lithium aluminum hydride. Yeah, both are reducing agents. Both are reducing agents. And sodium borohydride is less powerful compared to the lithium aluminum hydride table I have given. So based on that, you have to do this question. And sodium borohydride is a selective reducing agent. It selectively reduces some functional groups, not all. So which functional groups it can reduce? One is aldehydes and another one is ketone. Clear? Mainly. So that's why here, but in the reaction they have given ketone and also ester. But ester is not reduced by sodium borohydride. Only which one here? Ketone. So that's why ketones are reduced to alcohols. Aldehydes are reduced to alcohols. Ketones are primary alcohols. Ketones are reduced to secondary alcohols. So you already know. So what the compound you will get is, and here this will be converted into C double bond O is converted to CHOH. That is one. Plus, and here this ester group will not be reduced by sodium borohydride. Clear? So this only they have given, but I added here lithium aluminum hydride. You know that lithium aluminum hydride, it is a powerful reducing agent. It can reduce all the functional groups, means that is up to the acid derivatives, aldehyde group and keto, acid derivatives. It can reduce. Okay, so that's why, and both the functional group will reduce here. One is double bond O is converted into OH, and this is ester. Ester also will be reduced to alcohol plus mixture of alcohols you will get CH3OH. This is the answer. Simple next one, sodium borohydride, only functional group is aldehyde here. CHO group means which one? Aldehyde. So sodium borohydride can reduce the aldehydes into alcohol. Triple A process I mentioned, follow that one. So what it is? CH3, CH2, CH and CH3, it is converted into alcohol. This is the main one. And see the 11.4 that you can easily do. Show how are the following alcohols prepared by the reaction of soda glycanol reagent on methanol. On which one here? Methanol. Methanol means what it is? Formaldehyde. Methanol. This is HC double bond H. By using this, and you have to take the glycanol reagent and you have to prepare the first compound is CH3, CH3 and CH2OH. Okay, and we have already discussed when we treated the formaldehyde or methanol with the glycanol reagent, we get the primary alcohol. This will be converted to alcohol CH2OH. Means this part comes from the formaldehyde. Means this part should come from the which one? Glycanol reagent. That's what we know. So here CH3, CH and CH3 MgBr. Then you will get this compound followed by hydrolysis. Yeah. Next one they have given here same. You have to take the methanol, but from this you will get compound is CH2OH. Remember always CH2OH always comes from the formaldehyde. Means it is coming from the formaldehyde. It is coming from the formaldehyde. Means this part should be a glycanol reagent. What is the glycanol reagent? And this is MgX. If you take this and followed by the hydrolysis, you will get this compound. This is a positive charge and this is a negative charge. And this negative charge added here. This is converted to CH2OH, and there will be a bond between this carbon and cyclohexyl group. So these are the two questions they have given in the holidays NCERT textbook, page number 3. Now, physical properties of alcohols and phenols. Okay? The main physical property we have to discuss here is boiling point. So it is denoted by BP, boiling points. And previous also we have discussed in the haloalkanes and halogens about the boiling points. Boiling points mainly depends upon the attractions. Means we can say van der Waals forces. as the van der Waals forces increases, automatically boiling points will increases. You know, van der Waals forces depends upon the length of the chain. As the length of the chain increases, the van der Waals forces increases, then automatically boiling points will increases. So that means here the boiling points of the alcohols and phenols increases with the increasing in number of carbon atoms, or we can say molecular mass of the phenols and alcohols. And clearly directly we can write the boiling points of alcohol phenols are increases with increasing in molecular mass, or you can simply say molecular mass, or you can simply say number of carbon atoms. Clear? Simple example I will write. If I take here compounds like CH3OH and here CH3CH2OH, and the next one is CH3CH2CH2CH2OH. So these are alcohols. Clear? You know that chain length, as the number of carbon atoms increases, chain length increases. When chain length increases, automatically which one? Molecular mass increases. As the chain length increases, the van der Waals forces also increases, then automatically boiling points will increase. So among this, which alcohol will have the high boiling point? So this one, because it is having surface area is large here. Whenever surface area is large, then automatically van der Waals forces increases. So that's why boiling points also increases. Yeah. So that's why what is the boiling point? R means the last one will have the high boiling point than the second one, and first one. Yeah. And another concept also you know. As the branching increases, the boiling points will decreases. As the branching increases, automatically surface area decreases. When surface area decreases, van der Waals forces also decreases. So automatically boiling points decreases. And that is the second concept. So boiling point decreases with increase in branching. Yeah. Suppose if I take a compound is CH3CH2CH2CH2OH, it is a butanol, and another compound I will take CH3CH3 and CH2OH, and next one is CH3 and CH3 and another compound I will write here OH and CH2CH3, and the last one I will write the compound is CH3 and here CH3 and here OH. This is, see the compound here. One is N-butyl alcohol, isobutyl alcohol, secondary butyl alcohol, tertiary butyl alcohols. What is the boiling point R? As the chain increases, automatically, what happened here? Surface area increases. And if you are coming here, then automatically what happens? You see, branching increases, surface area decreases, automatically boiling points also decreases. So that's why the first one here will have the high boiling point, then the second one, and and I will discuss here primary alcohols and here secondary alcohols. Primary alcohols will have more high boiling points than the secondary alcohol. Secondary alcohol will have the high boiling points than the tertiary alcohols. So another concept is here the boiling points of alcohols and phenols. The boiling points of alcohols and phenols are very high compared to the other compounds, namely hydrocarbons, ethers, haloalkanes and haloarenes, and compared to those molecules, alcohols and phenols will have very high boiling points. Okay? Why? Because the OH group present in the alcohol and phenol involved in the intermolecular hydrogen bonding. Very, very important. Sometimes they will ask the question in the PU examination also. Why alcohols have high boiling points than the other molecule? Other molecule means like hydrocarbons, ethers. The simple one line you have to write, one sentence you have to write that, and alcohols involved in intermolecular hydrogen bonding. What is the intermolecular hydrogen bonding? Simple. I will write here alcohol. Alcohol, what is the common general representation? ROH. Okay? This is ROH. I will write here another one molecule. This is O and you know R. And I will write another molecule and R. And here H and O and R. Keep on writing this. Then what happens? And here H and oxygen, highly electronegative atom, oxygen, and hydrogen which is attached to highly electronegative atom involved in hydrogen bonding. So this is hydrogen bonding. So intermolecular hydrogen bonding existed among the alcohol molecules. Means some extra bonds are coming here. So extra bonds are coming means you have to use high temperature to break that bond. So that we will consider as a boiling point. So that's why. And here intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Due to this, and phenol alcohols will have high boiling points than the alkanes and ethers of the comparable masses. Okay. So another same phenol also. Write the phenol here. Phenol. It is there will be a O. I will write in this way, simple way. So one is oxygen and there will be a H, and I will write here another phenol like this, and there will be a H and O, and there will be a phenol and H, O, and there will be a benzene. This is phenol, same like alcohol. So here also there will be a chance of hydrogen bonding. So there is a chance of hydrogen bonding, which you already know. So what it is? Intermolecular hydrogen bonding. As the intermolecular hydrogen bonding existed, then you have to supply more amount of the heat energy to break this bond. So automatically boiling points will increase. So that's why here a simple question, and sometimes in the PU examination also they have asked. So alcohols are having high boiling points than the ethers and hydrocarbons and alkyl halides also. Clear? What is the reason? Because alcohols involved in the intermolecular hydrogen bonding. And suppose sometimes what they will give compound CH3, CH2, OH, and another one they will give CH3CO, CH3 and CH3, CH2, CH3. These are the compounds. They will ask, write the order of boiling points. Here, this is which one? Alcohol. This is ether. This is a simple alkane of comparable masses. If you calculate, the molecular mass is 46, and here also it is 46. Almost it is 44. Comparable masses, you have to compare the boiling points. Then alcohol will have the high boiling points than the ether, and ether is slightly polar than the alkane, so that's why ether will have high boiling points than the what it is here alkane. And this is the alkane. Why means because of intermolecular hydrogen. Right. So next concept is here solubility. So boiling point we have completed, and here next one is solubility. Boiling point order, if you consider, primary alcohol will have high boiling points than the secondary alcohol than tertiary alcohols. Why? Because as that means if you are moving from the primary alcohol to tertiary alcohols, branching increases. When branching increases, surface area decreases, automatically van der Waals process decreases. So that's why boiling points will also decrease. Next one is solubility. Okay? Solubility means the extent of solubility of alcohol. If you consider the lower alcohols. Clear? Lower alcohols means take the methanol and ethanol. Means compounds containing less number of the carbon atom alcohols easily are highly soluble in water. Okay? So lower alcohols are highly soluble in water. Highly soluble in water. Highly soluble in water. Yeah? So as the molecular mass increases, then the solubility of alcohols decreases. As the molecular mass of alcohols increases, then solubility decreases. Why it decreases? That we have to discuss. Clear? The solubility of the alcohols in water is due to the formation of hydrogen bonding with the water. What is the main reason to soluble here? Alcohol has to make a hydrogen bond with the water, then it is easily soluble in water. So suppose I will take here methanol or ethanol. I will take ethanol here. If I take ethanol, so you know what is the formula? CH3CH2 OH. CH3CH2, what it is? OH is there. Clear? And if you are consider hydrogen bonding, what I will add here? What I will add? Yes, you know this is oxygen is having 2 lone pair of electrons. Means it has to soluble in water, means it has to make a hydrogen bond with the water molecules. Then only it will be soluble. Clear? Now water if I add, water means you already know what is that one? This is H. Clear? And another 2 water molecule I will write. Whenever I write the 2 water molecule, you see I will write here H and OH. And another one, H and OH. See, there is a hydrogen bond between the OH of ethanol and oxygen. And here there will be a lone pair, it donates lone pair and will form a hydrogen bonding. And here also it will form a hydrogen bonding. Oxygen will form hydrogen bonding. So this is methanol can make a hydrogen bond with the water molecule. So that's why it easily dissolves in the water. But what the kind, because it is a lower alcohol means what it is? Small alkyl group. Methanol and ethanol. Methanol means small. Ethanol also somewhat small. But as the molecular mass increases, means number of carbon atoms increases. When number of carbon atoms increases, then what happens? This alkyl group and this alkyl group prevent the OH to make a hydrogen bonds with the water molecule. Then automatically what will happen? Solubility decreases. Means the solubility decreases with lengthening of carbon chain of alcohol. If the carbon chain increases, automatically what happens here? And it prevents that the hydrocarbon part prevents the alcohol to make a hydrogen bond with the water molecule. So that's why automatically solubility of alcohols decreases with the increasing in molecular mass. Clear? And now if you take one small concept. So primary alcohols are there, secondary alcohols and tertiary alcohols, which is highly soluble in water. You know primary alcohol, same I will take CH3, CH2, CH2, CH2OH. This is a n-butyl alcohol. And secondary alcohol I will write CH3, CH, CH2, CH3, and third one CH3, CCH3, and CH3OH. So which one can form? Which one can easily soluble in water? Okay, you know here length is increasing and here the length decreases, surface area decreases, and here surface area increasing. When the surface area of alkyl group increases, then it prevents the OH group to make a bond with the water molecule. So automatically solubility will be less. But here surface area will be less. Here no surface area is less here. So that's why. And it will allow somewhat OH to make a hydrogen bond with the water molecule. So that's why the solubility order is here. Primary alcohol will have less solubility than the secondary alcohol than tertiary alcohols. Tertiary alcohol. But this is which order here? Solubility order. This is a which order? Solubility order. But you know boiling point order is quite different. Boiling point order is which one? Boiling point order is primary alcohols. You know will have high boiling points than the tertiary alcohols and secondary. This is solubility of the which one? Yeah. As the lower alcohol is easily soluble in water, lower alcohol is mainly which one? Methanol and ethanol. Methanol and ethanol. C2H5OH. Remaining alcohols and solubility slightly decreases as the molecular mass of alcohol increases, solubility decreases. Why they are soluble? Methanol and ethanol are highly soluble in water because they are forming. The extent of hydrogen bonding with the water molecule is high when the alcohol is lower. That is the. So next one, here based on boiling points, they have given one exercise in the NCERT textbook. That is 11.3 page number 326. What they have given is arrange the following sets of compounds. They have given some sets of compounds here in the order of the increasing order of boiling points. Increasing order you have to write. Okay? To write increasing order, whatever it may be order of the boiling points, first you must know what are the formulas of these compounds. Yeah? Right here, pentane 1-ol. You already know what is the pentane 1-ol. Pentane means how many carbons should be there? There should be a 5 carbon atoms and 1 ol. Which ol means what it is? OH group, alcohol group. So ol should be present on which carbon? First carbon, that is the OH. This is the pentane 1-ol. Next one, butane. Butane means how many carbons we have, right? 4 carbons. CH3, CH2 and CH2. And there will be a OH on which carbon? First carbon OH will be there. This is 1. And next one, butane 2-ol. Butane means how many carbons? 4 carbons. 2-ol means OH should be present on which carbon? Second carbon. That is butane 2-ol. Clear? Ethanol. Ethanol means you know CH3, CH2, OH. And propane 1-ol. CH3, propane you know 3 carbon atoms and OH should be added to the first carbon. Next one is methanol. This is. So just now only we have discussed about the boiling points. Boiling points mainly depends upon the and intermolecular hydrogen bonding and also van der Waals forces. Yeah, and you know that in these compounds, as the length of the chain increases, van der Waals forces also increases, then automatically boiling points increases. Clear? So everywhere hydrogen bonding is common. So that's why you have to consider the van der Waals forces here. So as the length of the chain increases, van der Waals forces increases, then boiling points increases. Now here, length, how many carbon atoms are there here? 5 carbons. And here, length of the chain here, 4 carbons. But here also how many carbons are there? 4. And here 2 and 3 and here last one is 1. So which one should have the highest boiling point? Which one will have the longest chain? That is which one? Pentane 1-ol. Means I will write the numbering 1, 2, 3, 4, 5 and 6. So you have to write in increasing order. Which one will be the highest one here? The first one. First one is the highest one. What is the next one? Next one will come the 4 carbon chain length. So here also 4 carbons and here also 4 carbons. Which one will come? Which one will have the high boiling points? Primary alcohols will have the high boiling points than the secondary alcohol. So that's why it is a primary alcohol and it is a secondary alcohol. So that's why next will come here butane 1-ol, means it is a 2. Yeah. Next one. Here 4 carbons and here 3 carbons. And next will come 4 carbons means butane 2-ol. That is you will get 3. Yeah. Next one. 5 carbons, 4 carbons over. Next one. 3 carbons will have highest boiling points. Next one means here propanol. Propanol means where it is. This is 5. Propanol means 5. Next one. Ethanol and methanol. Ethanol is lengthy chain compared to methanol. So next will come here 2 and last one will have the 1. Sorry. Last one methanol. Methanol means what it is 6. This is. So you have to just understand boiling points mainly depends upon the van der Waals forces. Van der Waals forces depends upon the chain length. If you have that concept in your mind, you can easily do. But here primary alcohol and secondary alcohol having the same carbon length chain, but primary alcohol will have a boiling point than the secondary alcohol. Why? Because here secondary alcohol is due to the bulkiness and they cannot form the hydrogen bonding. Extent of hydrogen bonding is less here in the secondary alcohol compared to the primary alcohol. Next, another one they have given. One is phenol. Phenol means the same formula you already know. Pentane 1 on CH3 CH2 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 OH. This is phenol 1 2 3 4 5. Butane and butane means simply CH3 CH2. But means 4 carbon, A means alkane. Butane, butanol, all Al all they have given. All means aldehydes. So pentanol means CH3, CH2, 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 CH2. 1 2 3 4 5 carbons. That is pentanol. Ethoxyethane. You know, ethoxyethane. This is ethoxyethane. Yeah, these are the formulas of mixtures of given compounds. Now you have to arrange this one also. I will give numbering here. This is 1, this is 2, and 3 and 4. Okay. So alcohol will have the high boiling points than the aldehydes, because aldehydes in the alcohol there is a chance of, means they can easily form the intermolecular hydrogen bonding, but aldehydes cannot. So that's why first one will have the highest boiling points, and the next one compared to the aldehydes, alkanes and ethers, aldehyde will have high boiling point. Why? Because it is a more polar molecule. Aldehyde means what it is? C double bond O. This is R group and H. This is a polar negative charge, and here you will get the positive charge partial. If polarity is high, then there will be a dipole-dipole attractions. Then attractions are there and will have more boiling point than the hydrogen bonding will have. Hydrogen bonding is the strength of bond, which if you take the strength of the bonds, hydrogen bond will have the high strength compared to the dipole-dipole interactions. So here dipole-dipole interactions and here hydrogen bonding, it will have more strength compared to the dipole-dipole. So that's why greater strength means to break that bond you have to supply more high temperature, automatically boiling points will be high for alcohol compared to the aldehydes. So that's why. And third one and the next, this is alkane and this is ether. Ether slightly polar, more polar compared to the alkane. So that's why 4 and last one will have this is the boiling point.